Just first of all, I want to teach you how to use the calculator here. I'm going to put myself down in the lower right corner. 2 plus 3, it's 5. But what's nice is if you use the calculator, it'll figure it out for you. And where this becomes very important, like 5 over 2 is 2.5 slash, okay? And then you're going to have some square roots in here. And the way to get a square root in here is you type in square root, and it magically turns into a square root. And then you can do like 9, and you can see it's 3. And then what's really important is to realize that square root of 10, well, that's going to be a little bit more than 3. And when I type it in, it's 3.16228. And this is what's called an irrational number. This number goes on forever. It never ends. So when I write that the square root of 10 is 3.1 or 3.2, whatever, round it to, no matter what I round it to, I can round it to 3.16223. It's still a rounded number. It is no longer exact. The second I put it as a decimal, it is no longer exact. The only way I can write square root of 10 where it's exactly the number that I mean it to be is to write it as square root of 10. That's super important, and this is part of what this lesson's about. Okay, so they have this kind of interesting thing where they've got this little dot boards, and they draw a little triangle in here, and I'm going to try to draw on this. I got a 1 here and a 1 here, and we know how to figure that out because this is a right triangle. So we know that 1 squared plus 1 squared is equal to, c squared. Okay. Important thing: 1 squared is not 2; it is 1 plus 1 equals c squared. And I'm like 2 equals c squared. And this is where you'd be really tempted to think this is 2, but it's not. 2 would actually be a little bit longer if you were, 2 is this long, which would actually go out to here if this was too long. I've got to remember, I've got to undo the square with the square root of both sides. So those are inverse operations. C is equal to square root of 2, which is a number that we would normally write as 1.4, but we're going to instead write it as square root of 2. And the reason I showed you how to do that square root thing is at some point you may accidentally delete this, in which case the way you get it back is square root 2. And then hit check. Woohoo! All right, let's go to the next one. How do I get to, here. I'm going to start my timer here, and I was supposed to, I was going to go for 10 minutes or less than 10 minutes because I wanted to make sure I didn't go too long because that's annoying. So I'm going to set it for 9 because I've already probably talked for at least a minute already. Okay, let me clear this out. All right, so we've got another thing. So we already know how long this side is down here. We already know because we had that triangle there before. We knew that this thing right here, oops, let me share my screen again. We knew that this thing right here was square root of 2. We knew it was square root of 2 because if I drew the little triangle down there once again, 1 and 1, we worked it all out. We know this is square root of 2, which means we know this is square root of 2, and this is square root of 2, and this is square root of 2 because I've got little tiny invisible triangles all the way around that. Okay. Okay. So the side length here is square root of 2. And then the area, now there's a couple of ways I can figure out the area. This is a square. So if I do side times side, it will give me the answer. So I know the answer is square root of 2 times square root of 2. So if I know what that is, I could figure the area. The other way I could figure out the area is, well, this whole thing is 2. This whole thing is 2. So this big triangle is 4. But then I've got all these little triangles that I need to subtract out because they're not part of the square. And each one of these little things is 1/2. So 1/2 and 1/2 and 1/2 and 1/2. That's 2 minus 2. Oh, that's 2. So square root of 2 times square root of 2 should be 2. And it is, because one of the properties of square root is I'm going to have both things underneath what's called the radical. That's what that little square root sign is called. Or I can put them together. I'm multiplying these together. I can also write this square root of 2 times 2. These are equivalent forms, and that becomes important. Identical. You put square root of 2 times square root of 2 in the calculator, you get the same answer. If you put square root of 2 times 2 in the calculator where the 2 times 2 is underneath, same answer. Now, some of you are saying, well, wait a second. I already know what this is. That's going to be square root of 4, which that's got to be 2. So once again, I can do 2 kind of visually, or if I recognize kind of this trick of getting both these numbers underneath the radical, and then if I happen to get what's called a perfect square, I'm like, that's got to be 4. And if I type those in, it should check. What will not check, which is interesting, if you type in square root of 2 times square root of 2, which is equal to 4, and it should evaluate it as that, it won't check here. It'll give you a little X up here. I don't know why. It should. Okay, let me clear all. And go to the next screen. And so now we've got a bigger one. And so we're going to do our same trick again. We're going to say, I'm trying to figure out the side length. Well, if I make a little triangle right there, this is easy enough. This is a side of 3. This is 1. Oh, hypotenuse. 3 squared plus 1 squared equals c squared. So what's that side length going to be when I finish evaluating it? That's right. It's going to be 9 plus 1 equals c squared. So 10 equals c squared. That side is obviously not 10. It cannot be 10 long. I've got to take the square root of both sides. And I'm like, oh, c is equal to square root of 10, which is a number, which we already know is about 3.2. If we write it as a decimal, it's a little bit less than that. But that's roughly what it is. So this thing right here is square root of 10. The area. So I can do that whole trick again. Could enclose this whole thing and say, well, this whole thing is 4 by 4. It's 16. The green part is a little bit less than that. I could subtract out these triangles. I could do it that way. But we know that other trick. We're like, well, this is square root of 10 times square root of 10, which I'm like, oh, I know that trick. Square root of 10 times 10, which then I recognize, oh, that's the same as square root of 100. Oh, that is 10. That's interesting. Notice another way you could write that. Square root of 10 times itself is square root of 10 squared. That is also equivalent. And that's the same trick we did here. Square root and squares are inverse operations. So this guy here and this guy here, they cancel each other out, which is why we're just left with 10. There's lots of ways to get to that 10. Now the perimeter, you just got to add them up. I got square root of 10. I got another square root of 10. I got another square root of 10. I got another square root of 10. I have 4 square roots of 10. This is just like getting 4x. I have 4 of these things that are all 3.2 long. 4 times the 3.2, which I'm going to write as square root of 10, would tell me the perimeter. So it's going to be roughly 12.8. Okay, because when I multiply that times 4, it's roughly 12.8. But it's going to be something a little bit different than that. And if I type those all in, this should check. Now, once again, let me show you this. No, I'm not. I'll let you figure it out yourself. Okay, let me clear all. And next. All right, so this one, once again, I'm going to let you figure this one out, but this is looking for 2 different ways to type in that side length. This is kind of a fun little challenge. I'm going to let you figure that on your own. The green thing, ignore it. The green thing is referenced from the last one. We know this thing is square root of 10, so how long does the purple have to be? If the green thing represents 1 square root of 10, how long is that purple side got to be? Right, it's got to be 2 times the square root of 10, because it's twice as long, okay? Now the question is there a different way to write that? And there is, and I'll give you a hint here. 2 times square root of 10. Well, I'm like, well, if I wanted to get that under there, well, it doesn't have a radical there. Well, can I get a radical there? That's one way to do it, is I could say, well, that's square root of 4. That's equivalent. That's one way to figure it out. The other way to figure it out, I'm going to leave that there, is notice I have one big triangle here. I have one big triangle here that's 2 long and 1, 2, 3, 4, 5, 6 high. So if I have a right triangle that's got 2 on one leg and 6 on the other, how long is that right there? Right, it is square root of 40, which is what that is too, okay? All right, I'm probably about to run out of time, so I'm gonna jump ahead. Just want to give you a sense of these things. I'm gonna let you figure that out yourself. This is a little weird. You gotta, my hint here, if you want to go back and do this, everything needs to get tilted, okay, including the green square. They're trying to make you recreate something that looks a little bit like this one. They said slide 5, but it's actually slide 6. Oh, I know why. It's because I need to fix that. This should actually say go back and look at screen 6. All right. There is a very good little video here you should watch. And then the last thing I want to show you is this one. I think you can check out is this one. Okay, I'm going to do this till I run out of time. Clear all my columns. So this is matching. And so there's a bunch of equivalent forms here. And the reason this is important is because they're just different ways to write things. And you need to be able to recognize those things when they're written. And in the same way that you recognize that 1/2 and 2/4 and 0.5 are all the same number. They're written different ways. And any one of them could potentially be a way to be expressed. Any one of them could potentially be an answer on a multiple choice test, in which case you just have to recognize, oh, those are all the same answers. They might write them in different ways. There's a bunch of things here that are the same answers. I'm just going to pick this one right here. Square root of 25 times 2. Well, I know what that is. Those two get multiplied together. That's square root of 50, which I think is one of these things down here somewhere, maybe hiding under my picture. Oh, no, it's there. Square root of 50. I'm going to match those cards up in a minute. Now there's one more card that matches here. And the thing is, remember, we can break this apart. We can say, well, this is the same as square root of 25 times the square root of 2. That is a legal operation. Those are still the same things. If I put this in the calculator or put this in the calculator, they'll both come out to the same number, which is about, what is that number very close to? That's right. That's about 7.1. This is about 7.1. This is about 7.1. They're all different ways to express an approximation of 7.1. But when I write it this way, what's square root of 25? Well, it's 5. So square root of 25 times square root of 2 is the same as 5 times the square root of 2. If I put this number in my calculator, I get 7.1. So I can match all these ups. And I really want you to go back and do this on your own, because it's important that you know how to recognize these. It's just a different way to recognize things. So once again, there's my square root of 25. Oops. That's going to go with my square root of 50. And then I should have a 5 root 2, which I have right there. And what's nice, if I go to the next page, it will say to me, hey, I got 3. I need to get all 12 right, so I can go back and do it. And then I'm also going to encourage you to go out and look at this page. This page right here, once again, this can be broken apart, because this right here is the square root of 4 times the square root of 6. So notice that? It's not saying it's right, because that square root of 4 can be written a different way. How else can that be written? Right, that can also be written as square root of, that can be written as 2. Square root of 4 is 2. I'm hoping this is going to check, fingers crossed. Yay. And so for each one of these, this is going to be a combination of a perfect root and a imperfect one. Now, this is interesting. I haven't seen one like this. This is 6. 27 is 3 times 9. So square root of 9, 9's. This is square root of 9. Oops. Square root of 9 times 3, right? But that square root of 9, I can say, oh, I know what the square root of 9 is. The square root of 9 is 3. But if I write it as 3, it can't be underneath the square root anymore. I've actually evaluated the square root. So the 3 comes out front. Doing all multiplication. I don't think this will check. No, it won't, because that needs to be actually written. 6 times 3 is 18. And I would challenge you as you do these is to actually take a calculator out and say, when I put 6 times 20 square root of 27 in the calculator, is it the same as 18 times the square root of 3? And it is. They're all going to be the same decimal approximation. All right,